Hi there, hope you have a fantastic day today. This lesson, I will teach you how to find the mode of a probability density functions. Of course, there is a PDF file versions on the description below for you to download so you can work with me. Otherwise, let's get straight into it. A mode of a probability density functions is the x value that gives the maximum value of f of x. F of x is probability density functions. For example, if you have a look at this graph here, so this probability density function graph, the maximum value is at this point. So that is this value here. So therefore, the mode is 3. So therefore, the mode for this probability density function graphs is 3. Keep that in mind. Please pause the video and try this to yourself. Hi there, I'm back. How do you go? So let me just go through them with you, okay? Before I do that, please do not forget to give me a thumb up and subscribe if you haven't done so you can help me to grow my channel. So let's get into it. So part B. So we know that the maximum turning point or the maximum f of x is at this point here. So therefore, the mode of this probability density function is 4. And part C, so the maximum value is at this point here. Okay, this will give you the maximum value of f of x. So therefore, the mode, we'll be looking down here. So therefore, the mode of this probability density function graphs is 6. Question number 2. So we know that the probability density functions is x squared, and then within the domain of 3 and 8. So to work out the mode for this, so first of all, if you think about it, let me just do a quick sketch, okay? So let me just do a quick sketch for x squared. So x squared is this. But then it's from 3 to 8. So we know that this is 3 here, just a rough sketch, and 8 here. So therefore, this is the maximum. Let me just clear this. I just draw within the domain. So I change that. So this is it. So therefore, this is the maximum value of f of x. So therefore, the mode is 8. So therefore, the mode for this probability density function is 8. Question number 3. So we have the probability density functions is this, and we need to work out the mode for this. And we know that the mode of a density functions is the x value that gives maximum value of f of x. So to work out the maximum value f of x, we know that the gradient is equal to 0. Or, of course, you can find the axis of symmetry, x equal negative b over 2a, and then that will give you the mode, okay? So we just need to work out the axis of symmetry, if you like. Otherwise, we can just use calculus, we just differentiate this. So let me just use calculus to do this, okay? So first of all, let me just write down f of x is equal to 2 over 27 negative x squared plus 3x plus 4. So if we differentiate this, and we know that this is a constant, so we just write this down first. So let me just write f dash x is equal to, I just write this down because it is just a constant, and we differentiate x squared. So x squared will bring the 2 down and we minus 1, so it become 2 times x power 2 minus 1 is 1, so 2x power 1. Okay, so that is 2x, but the negative in front, we just write this down. So negative 2x. And if we differentiate 3x, so that will give us 3. And differentiate 4, it gives me 0. So there you go. And to work out the maximum value, remember, the gradient must be equal to 0. In another word, f dash x is equal to 0. So therefore, 2 over 27 negative 2 x plus 3 is equal to 0. So now to solve this, if I divide by 2 over 7 on both sides, so this will cancel out, and we divide this by 2 over 27. Of course, 0 divided by any numbers is equal to 0. So in another word, negative 2x plus 3 is 0. So I just move negative 2x on this side. So that will give me 3 is equal to 2x. So to solve for this, I divide by 2 on both sides. I divide this by 2. I divide this by 2. Cancel out. So therefore, x is equal to 1.5. So we need to make sure it is on the maximum turning point. So to do this, of course, we second derivative to test, make sure it is maximum. So let me just write f dash x down first. So f dash x is equal to 2 over 27 negative 2x plus 3. So let's differentiate this again. So f double dash x is equal to, now remember this is just a constant, so let me just write this down. So 2 over 27, now we differentiate, negative 2x will give me negative 2, and then we add, differentiate 3, it gives me 0, so that is just that, because negative 2 plus 0 is negative 2 anyway. So that will give me negative 4 over 27. So therefore, it is maximum. So therefore, the mode is 1.5. Please pause the video and try this one yourself. Hi there, I'm back. How do you go? So let me just go through it with you. To work out the x value that gives maximum value of f of x, so we just differentiate this to make it equal 0. Okay? So to differentiate this, you either use product rules, or I can expand this one out first, then differentiate. So whichever way you do doesn't really matter. So let me just expand this out first. Okay? So let me just write f of x is equal to, I expand this. So I expand this one out. So that gives me negative 3 over 56 x squared. And I expand this. So that means negative times negative give you a positive. And 3 over 56 times 5, it's just like 3 times 5 is 15. So 15 over 56x. So there you go. So now let me just differentiate this first. So to differentiate this, I just go f dash x is equal to, we bring the 2 down with less 1. So 2 times 3 equals 6. Okay, so that is negative 6 over 56. And 2 minus 1 is 1, so x power 1. And I don't need to simplify because I'm going to solve this anyway. So it's easier if you leave like that because it's same common denominator. Okay, both are 56 for both terms. Okay, remember. So now differentiate this. So that gives me 15 over 56. So now we just go f dash x is equal to 0. So f dash x is equal to 0. So this means that negative 6 over 56x plus 15 over 56 is 0. So what I do, I just move this one on this side. So that will give me 15 over 56 is equal to 6 over 56x. So now if I times 56 on both sides, so that will cancel out. So keep that in mind. So now I just rewrite this in this way. So 6x is equal to 15. So now what I do, I divide by 6 on both sides. So if I divide this by 6 and I divide this by 6, that cancel out. So this means that x is equal to 6 go to 15 is 2 times, because 2 times 6 is 12. Remember 3, so 3 over 6. That means a half, or 2.5. So now we just test it, make sure it is maximum. So to test it, second derivative must less than 0, right, for maximum. So let me just differentiate this. Let me write f dash x first. So f dash x is equal to negative 6 over 56x plus 15 over 56. Now to differentiate this, let me move this up. So that becomes f double dash x is equal to, we differentiate this, negative 6 over 56x, we'll differentiate that, give me negative 6 over 56. And we differentiate this, that will give me 0. So the answer is negative 6 over 56. So this means that it is less than 0, so therefore it is maximum. So therefore the mole for this probability density function is 2.5. And thank you so much for watching, and I hope you got it correct. Bye!